When you hear about burying wood in soil, the first reaction is often skepticism. After all, wood is tough, slow to break down, and not something most gardeners think of as fertilizer. But buried wood is not a new idea. Ancient farmers, forest gardeners, and more recently the permaculture movement have all experimented with it. The promise is bold. Burying wood can transform poor soil into a sponge for water, a home for fungi, and a slow-release nutrient bank that feeds plants for years. We decided to test it ourselves, tracking a full time lapse to see exactly what happens when logs, branches, and wood chips are buried in the earth. What we discovered was a step-by-step transformation that may surprise even experienced gardeners. The idea of burying wood is rooted in natural forest cycles. In natural forests, fallen logs don't just rot on the surface, they become nurseries of new life. Moss, fungi, insects, and seedlings thrive on decaying wood, which slowly releases nutrients as it breaks down. So this is the principle behind hugelkultur, which is a traditional soil building method that layers logs, branches, and soil together in mounds or trenches. By mimicking this natural process in the garden, buried wood acts kind of like a hidden engine of fertility. It absorbs rainfall like a sponge, holds onto it during dry spells, and then gradually decays into humus. Our test was designed to see if this forest-inspired idea could actually be harnessed in an ordinary garden bed, with clear, measurable results. The first stage of burying wood is microbial colonization. In the first few weeks after we buried wood beneath the soil, there was honestly not much to see above ground, but there was a lot happening beneath the surface. Fungi were the first to arrive. Filaments of white mycelium started spreading across the buried logs, breaking down lignin and cellulose, which are, the hardest parts of wood. Bacteria followed, feeding on the simpler sugars that were released as fungi did their work. At this stage, worms hadn't yet appeared in significant numbers, but the groundwork was definitely being laid for them. The buried wood began to soften, holding moisture more effectively and already changing the microclimate underground. After about 2 or 3 months, the buried wood started to attract larger soil organisms. Earthworms tunneled through the surrounding soil and began working the softened edges of the wood. Beetles, springtails, and other decomposers were drawn to the rich fungal network that had formed. This was the point where the wood truly became part of the soil ecosystem. Instead of being a solid, lifeless mass, it turned into a living habitat. As worms fed on the microbial layer coating the wood, they transported nutrients outward into the surrounding soil, effectively turning the buried wood into a distribution hub of fertility. By the 6-month mark, our time-lapse revealed a striking difference in soil moisture. The bed with buried wood stayed consistently damp even during dry spells, while the control bed without wood dried out much faster. This was due to the sponge effect of the wood. As it broke down, its porous structure acted like a reservoir, soaking up excess rainfall and then slowly releasing it back into the soil. In terms of structure, the soil became looser, darker, and easier to work. Roots began to spread more freely through it, clearly benefiting from the improved aeration and consistent moisture. After a year, the buried wood showed clear signs of decay. Logs that had once been hard and dense could be crumbled by hand. This was the point where nutrient release accelerated. The breakdown of lignin and cellulose produced humus-like material rich in carbon. Fungi continued to supply phosphorus and other nutrients while nitrogen-fixing microbes colonized the surrounding soil. Interestingly, the plants above the buried wood showed deeper green leaves and stronger stems compared to those in the control bed. This proved that the nutrients locked in the wood were not wasted, but gradually cycling into the soil food web. One challenge we noticed in the early months was nitrogen drawdown. Because microbes need nitrogen to decompose wood, they temporarily pulled it from the surrounding soil. This caused mild yellowing in some plants during the first 6 to 8 weeks. To address this, we added a nitrogen-rich layer of fresh grass clippings and manure above the buried wood at planting time. By the end of 2 years, the buried wood had almost completely transformed into rich, dark humus. What began as logs and sticks became soil indistinguishable from naturally fertile forest earth. This humus acted not just as fertilizer but as a long-term stabilizer, improving cation exchange capacity, increasing microbial life, and maintaining water-holding capacity. Plants in the wood-amended bed continue to outperform those in regular soil, showing resilience to both drought and heavy rains. The time-lapse made it clear. Burying wood is not a quick fix but a long-term investment that pays off year after year. The takeaway from this experiment is that any gardener can harness the benefits of buried wood. It does not require special equipment or exotic materials, just fallen branches, logs, or even coarse wood chips. For best results, wood should be buried at least a foot deep, paired with nitrogen-rich material and covered with good topsoil. Burying wood in soil is not a gimmick. It is a proven, natural process that works with the forces of decay to create long-lasting fertility. From fungal colonization to worm activity, from moisture retention to humus formation, every stage contributes to healthier soil and stronger plants. Our full time-lapse confirmed what ancient farmers and forest systems have shown for centuries. Wood, when buried, becomes soil. And that soil, in turn, becomes the foundation of abundance. If you found this experiment useful and want more time-tested soil revival methods, make sure to subscribe to Soil and Plant Doctor and share this video with fellow gardeners. The secrets of living soil are right beneath our feet. Sometimes all it takes is the courage to bury a log and let nature do the rest.